Good evening and welcome to today's class, everyone. Please confirm if you can hear me. Please confirm if you can hear me. All right, great. Today we'll be moving on with what we've been learning throughout this week, Monday, Tuesday. Today we'll be doing a revision, right, of everything we've been doing, and then we'll move on to how to evaluate these translation systems that we've been learning about since Monday. But before we move on to what we have to do today, I know we all already have this notebook, so I'll be sharing my screen now. So please confirm if you have access to this notebook. Please confirm if you have access to this notebook. All right, so I will take it that we all have access to this notebook. Great. So before we move on to what we have to do today, please tell me one thing that you've learned, just like I usually ask, one thing that you've learned that you can remember throughout Monday and then Tuesday. Please let me know one thing that you have learned. Tell me about one thing that you have learned throughout Monday, Tuesday. What's that thing that's okay? If you are asked, what have you learned this week? What are you going to say? Okay, I can see Oladide saying advantages of GPU over CPU. Okay, and what are the advantages? What did you learn that are the advantages? I should be seeing lots of responses about translation because we've done have the understanding that we've been taught that throughout Monday and then Tuesday. Tokenization. Adeboyewale is saying tokenization. Okay, Akinwale, difference between large language models and small language models. Okay. All right. Since we all are not, I think maybe we are still settling in. That is why we are not responding to what we've learned on Monday and then Tuesday. Right. Okay. So let me ask us question based on what I know that we've been taught on Monday and then on Tuesday also. So can you tell me the architecture rights used in transformers? Tell me the architecture rights that transformers use. Okay, Abubakar is saying you learned that Hausa Igbo are called. So Abubakar, I think you meant to say low resource language, right? Because we do not have lots of data on them, right? So they are called low resource language. But then, right, it depends on not it doesn't actually depend on the language, right? It depends on the model for you to be able to call it a small language model, meaning it doesn't have as much parameters as a large language model. But Hausa, Igbo, and Yoruba, they are actually called low resource languages, not small language models. What to look out for when choosing a model? Okay, so what do you look out for when you are choosing a model? And just tell me what to look out for. I learned that I should look out for this, and this when I'm choosing a model, right? Okay, I can see that we are coming up now. Okay, Oyewumi, Olajide. Yeah, GPU. What's the full meaning of GPU? Graphical Processing Units. Yes. In their term, you learned about the size of the model, the languages it can cover. Well, the marks, it's actually based on the tax, right? So on the tax that you used it for, right? No language left behind. That is NLLB is was accurate than a small language model that you used. We have different types of small language models. So on that specific small language model that you used, right? NLLB was better. The base model achieved superior results at a fraction of the training cost in the transformer. What do you mean by that? Philip. The base model achieved superior result at a fraction of the training cost. As far as I'm concerned, in the notebook that you have been going through on Monday and then Tuesday, you've not trained any model, right? You've just been using the model to get results. You've not trained any model specifically, right? So what do you mean by maybe you could use a clearer English? Oh, please confirm if you can hear me. I think I'm audible. Okay, Dorcas is saying you learned how to use the right LLM. All right. So what are the some people have hinted at it, right? NLLB, um, NLLB, and so you should check your network. Simon, yes, please check your network, Simon. So what are the different models, right, that you worked with throughout Monday and Tuesday? Can you tell me some of the models that you worked with, right, on Monday and then Tuesday? Yan GPT. Can you use Yan GPT for well, okay, yes, even though it's speech, and then you can also use the speech, SPITCH, speech. But no, Yan GPT is not used for translation, is it? No. Yeah, Yan GPT is basically a text to speech, right, model. But for speech, SPITCH has some translation capabilities. But no, Yan GPT does not do um translation. You can confirm that, Abubakar. NLLB meant to say no language left behind. Adekola, well done. Yeah, okay. So most of us are mentioning NLLB. So apart from NLLB, we've not gotten to the other part of the notebook. where we used T5. Okay, all right, excellent. So let's move on, right? We all have this notebook, and I'm sure that we have we've clicked on file and then created a copy of the notebook such that we know that whenever we are making changes to that notebook. Yeah, such that immediately we are making changes to the notebook, um, it will be saved there. All right. Yeah, so when you hear transformers, what comes to your mind? Let me see how well we have all interacted with this notebook and how well we have read, even if it's to scan through the attention is all you need paper. So tell me, when you hear transformers, right, what comes to your mind? Anthony, you're saying I should check my audio. My audio is coming on and off. Please also, I should check my network rather. Please confirm if it is same what Anthony is saying is also the same on your end. Is my audio coming on and off on your end also? Please confirm if you cannot hear me clearly and if my audio is coming on and off. No language left behind. Mika, yes, you can check the Anthony, please, you might want to check your own network. Yeah, No Language Left Behind has like over 200 languages. To be sure if it can translate from English to TIV, you can also check the model card on Hugging Face, right, to see the languages that it can translate to. Then you can make those changes in your notebook and then see the results. So I can see Olajumoke saying when you hear transformers, you remember the attention mechanism. You meant to say attention mechanism, yes. And then you also remember you wanted to say encoder and decoder, right? The encoder decoder architecture. Excellent, Olajumoke, to see that when you hear transformers, what comes to mind is that attention mechanism, multi-head attention mechanism, and then you also talk about the encoder and decoder architecture. So which models? We know that large language models, right, they mostly use the transformer, right, architecture. So can you tell me which models, right, use the encoder architecture, which models use the decoder architecture, and which models can use both? Yes, Philip, queries are not in sequence but in parallel. Excellent, which is one of the issues, right? That paper, attention is all you need, solved, right? Excellent. So tell me now, Alajumoke mentioned something about the encoder and then the decoder architecture of transformers. So I'm not asking you that, do you know the models, right, that use, let's say, the decoder part, or the models that use the encoder part, or the models that use both, that is the encoder and also the decoder structure, architecture rather, together? Oh, Omoneni, sorry if I did not pronounce your name correctly. The beginning of this recording has no audio, so kindly forward it. Oh, I think you're not talking to me. You're talking to the person that said there's no audio, right? Thank you. Yeah, so you could just check your learning management system, check your learning management system, DB visuals. I'm sure that our admin must have posted the notebook there. So please just check your learning management system and then you'll see, I'm sure you'll see the notebook there, right? So you've not answered my question, right? Which models, right, use the encoder architecture, which type of models use the decoder architecture, and which kind of models, right, that you have been taught Monday and Tuesday use the encoder decoder architecture together. Even wait, before I even go to that part, because you need to really understand these basics, right? And I've given us that attention is all you need paper since the very first week of this class, and this is the sixth week, right, of this class. Before I ask you about the models, I really love Olajumoke's response because she talked about the attention mechanism, right, which is what makes transformers different. I like Philip's response talking about our queries are responded to, right, in parallel. Well, they are processed in parallel. And then Olajumoke also mentioned the encoder decoder architecture. Before I even ask you about the models that use this architecture, what do you understand, right, by encoder and decoder architecture? The encoder architecture, what does it do for us? The decoder architecture, what does it do for us, right? So let me know what it does, what you understand, right, that it does. I can even still see it in our notebook, right? Right. I can see it in our notebook. So which is to say, we have been taught, right? Yes, I wasn't saying anything before. I'm sure you should be able to hear me now. Okay, so for lunch, you're saying NLMB, NLLB. NLLB, does it use the encoder part or the decoder or both? That's my question. And the encoder part, what does it do? The decoder, what does it do? Tell me, explain it to me. For Laurentia is saying encoder processes the response. More, I won't want to use for process. I want to say understands, right? It helps to what understand that text, right? Encoder, right? That's what we can see on this notebook that I'm displaying. It will help you to understand the source sentence. It understands the source sentence, reads it, right? Okay, how about the decoder part, right? Yes, the decoder is going to generate. Yes, exactly, that's the difference. The encoder will read the source sentence while the decoder would what? Generate. That is those two architectures. And we now know that there are some models that they only use the encoder architecture, and then there are some models that only use that decoder architecture, while there are some models that combines both. While you might not have been told the models that use the encoder and the ones that use the decoder, but I'm sure you must have been taught the ones that use both, because that is what translation models, right? That is what they use, right? So can you give me examples of these models? Eh? Okay, so I can see some more responses here from Philip. Philip is saying encoder breaks down the queries. No, no, that is not what the encoder architecture part, right, of the transformer, that is not what it does. Philip, right, you can see Tim's response and also what we have in your notebook. So that is what that encoder part, it will read, make sure it understands the source sentence, right? That is why you can use it for tasks such as sentiment analysis, because it understands, it was able to read that sentence to understand the kind of sentiment, right, that is there. And then you can use the decoder part for things that require generation, right? When you say, oh, maybe write me an essay about something, right? And then it writes you an essay. While there are some very great models, sorry, that can combine both architecture, encoder and the decoder. Yes, we have NLLB. Yes, it's a translation model. Exactly, the Facebook model, which is in our notebook. I think that is C5. Let me confirm. Yes, NLLB is still the Facebook model. And then, oh, you've not used C5, but C5 also is another type of model, right, that combines both the encoder and decoder structure. But apart from the fact that, yes, exactly, Sunday, well done. Yes. So apart from the fact that the models that use the encoder only architecture, they can read and understand the source sentence. That is why they can be used for tasks like, let's say, sentiment analysis. They can fill in the gaps, right? Awesome, in an awesome manner. Decoder models, right, they can do everything apart from just the generative part. Like, we use them these days, right, to do everything. And those are our large language models, right, that we use. This GPT, generative pre-trained transformer, your what is be working behind your Gemini, Claude, everything. They are decoder only models, and then they are generalists, right? We use them for everything, all the type of tasks that we've been learning since week one. Summarization, everything, question answering, classification, everything, we use them. So, and then while the models that combine the encoder and the decoder structure, right, the architecture rather, we know that um it can be used for translation. Apart from translation, why do you think they can be used for translation? Let me help you with that. They can be used for translation because they will first, they are combining both the encoder and then the decoder part, right? So they will first understand, right, that source sentence, right? Then the decoder part will now be the generative part, where they will now generate, right, the source sentence in another language, right? So models like that combine the encoder and the decoder part. Which other tasks do you think these models can be useful for? Which other tasks do you think they can be useful for, such that they need to first understand the source sentence and then now generate something new? So which other tasks do you think this kind of models that combine the encoder and also the decoder structure, which other tasks do you think they can be used for? Let me hear your thoughts on that. Summarization, excellent, Abubakar. Summarization, excellent. So because it will first need to understand the text and then generate the summary, right, in text, right. So Olajumoke and is saying speech to text. For speech to text, right, they say all um new process, right? But I can confirm that exactly. So excellent. We can use it for speech to text. That's correct, Olajumoke. Translation, yes, which is what we are currently doing. Same is saying maths or calculation because it's first needs to understand that task, right, before generating something as the solution. All right, so excellent. Automation can automate tasks and workflow. Large language models, no, I wouldn't want to believe they can do that, except it's something about agents, right? Something agentic, right? That can really come and automate tasks, right? And workflows. So, all right. So, great revision. Great to see we all understand this concept. And then it's great to see that we have also we all understand, right, what we've been learning. And then it's great to see that most of us have also gone through the attention is all you need paper to understand. When people are saying transformers, you know what it is about and kind of architecture, right, that they use. All right, so moving on to what we have to do today. Moving on to what we have to do today, I'll be running this first cell. Yeah, so I'm going to run this first cell to install all the libraries, right, that we need. And then run this second cell that will be importing our tokenizer and then other things we need from the transformers library, which was developed by Hugging Face. And we know that it was built on top of touch. Like that is why we can see this touch here. Okay, so we've discussed about the encoder decoder architecture. We all understand, I'm sure we understand the attention mechanism, right, in transformers, which makes it no understand, right, the next type of token to predict because it is able to look back at previous tokens, right, and then it makes it give contextual completions, right, to text. So we all have discussed about, so I'll just be doing a brief revision of what you've done Monday and then Tuesday, right? So you can just go with me or stay with me as I'm doing this revision. We've talked about the no language left behind um model, and you know that it can use, we have it's for over 200, right, languages. I think somebody was asking if it's used for thief. So let me know if you've confirmed, right, if it's used for thief, the person that asked that question. All you just have to do is go to organ phase, type no language left behind, then check the languages that we have there. If you've been able to do that, let me know. Okay, I should zoom into my screen a little. All right. So I'm sure we can all see this now. So yeah, we've been able to cover all this for Monday and Tuesday. Yeah. And then we also, let me see. So this first task is just trying to convert from English to Yoruba. I won't be able to use another language because I'm not Igbo, and I would not be able to tell if, oh, what is being translated, right, is correct or not, right? So we'll be using Yoruba because I am a Yoruba girl. But if you are Igbo, or if you are have a language of thief, just like the person that asked in the chat, you could check for the language code on Hugging Face, right? And then input it here instead of having Yoruba LATN, right? You could just change it to your own language that you can verify if it is giving you what is correct or not. And then we are using this Facebook model that we know that we have used. Yeah, so the next cell, we are initializing our tokenizer to be used. I'm sure everybody in this class will understand what tokenization means, right? We've said it over and over again across all class. But then this auto tokenizer, can anybody tell me what this auto tokenizer, what it does, right? What does this auto tokenizer do? What does this auto tokenizer do for us? Excellent, Mega J. It automatically loads the correct tokenizer for any model you want to use. Excellent response. Yes. Olajumoke, it checks in with the tokenizer. Yes, I think what you want to say is what Miguel J has said in a very good way. It automatically loads the correct tokenizer. Yes, excellent. So that is what the auto tokenizer, that is what it does. And then I'm sure we've been taught all this. And also the auto model for sequence to sequence language model. This part also loads, right, the correct weight, right, for the NLLB model name that we have specified above. And the model we specified here is the Facebook NLLB 200. Yeah. So it's going to load the correct weight, right, for this model. And we are using this sequence to sequence because NLLB is a model that combines both the encoder and the decoder architecture. together, right? So we have also been taught that. And then the next part is just trying to now do the translation from our source language, which is in English, and then to our target language that we chose, right, which is Yoruba. So we have here we are trying to tokenize, right, by passing in our text, and then we are trying to get the language ID here. Here we are now trying to say whatever you are generating, start generating it using that specific language ID. And then here with touch no grad, anytime you see with touch no grad, it's saying that we just want to get outputs, right, from that model. We are not training or doing anything, right? That's the simple meaning. And then you just generate the translation. This is where the translation is being generated. And then we now decode, which is to convert those IDs, right, into text. So we all understand that we've been taught. This is just a simple revision. And then from English, we are running this. We can see the response in Yoruba, right? And then moving on, you also did this, right? Maybe Monday or Tuesday, right? Where you would input an English sentence, right? And then it will be automatically translated for you. We'll not be rerunning that again because of our time. So we'll be moving on to this part, the machine translation in Pidgin for science, right? So this the difference between the above, right, and this new one that we want to do. I think you've done it, right? Because that is what your instructor told me, my colleague told me, is that we've also done this part, the machine translation in Pidgin. So the difference between the above and this one is that this one uses a specific model, right? Pidgin, right? While the above could use no language left behind, we have about like 200 languages that we can translate to. And then we do the same thing here, load our tokenizer and then our model weights, right? And then yes, so tokenize, after tokenize, get our response from our model, and then also decode, right, whatever output that we've been given. So for this part, we're just trying to translate this place from English. The rate of a chemical reaction rises because the practical up to the end frequency, right? And then you can see the translation in Pidgin that it is given. So I'm sure we've also done all this, right, in our class from Monday to Tuesday. We all know what tokenization is. We've done that over and over again, right? So here we are just trying to explain what tokenization does and how you can see it, right? You don't just want to be saying, oh, I know tokenization breaks, right, words, right? Can be a big sentence into some words, right, depending on the type of tokenizer, right, that you are doing to chunk sentences, right, into subwords, or is the smallest unit, right, of the word, which is a token. So we've done all this, you've done all this rather on Monday and on Tuesday. You saw how when you tokenize, right, the response that you would get and then the number of tokens that you have there. So moving on, most of us already mentioned this also. We talked about small language model and also um, no language left behind, and the difference between the result, right, that you got. And I think somebody also said that, oh, the result from I can't remember correctly again. I think the person said the result from the no, Abubakar. It is the tokenizer, right? Auto tokenizer is just the wrapper that helps to get the correct tokenizer that that model uses, right? So once it get that correct tokenizer that is being used for the model, then it is the tokenizer that will now be converting raw text into tokens, right? Not the auto tokenizer. Auto tokenizer is just a wrapper, right? Okay, so just like I was saying, yeah, I was trying to say somebody also said, um, I can't remember accurately. I was trying to say I can't remember accurately. Person said maybe it was the translation model that person used that got a better score than gave a better translation quality, right, than NLLB or vice versa. But there was some sort of comparison, right? And this is where that comparison took place, right? So we are using this model from David Adelani, one of the bosses, right, of low resource languages. So we are using this T5. So I know that I saw T5 model. That's why I kept on saying T5, T5. So we are using this model, right, this T5 model to convert from English to Yoruba. And then so what's the difference, right? You can see that in this part we are using just pipeline, right? We are using just pipeline, and then you did not need to um you didn't need to define your tokenizer differently and then now load your model weights. That is because this pipeline, right, already abstracts out everything for you. All you have to just do is put in the model and then what you want to do, right? And then you get your um results, right, from it. So this pipeline from Hugging Face also, it's abstract. If you remember from the beginning of this notebook, right, we already imported it. So this pipeline abstracts out most of those little steps. And here, of course, we are trying to convert from English to Yoruba. Hello, how are you? And then you can see the result, right, that you we got. Ẹ ló báwo ni ẹ ṣe rí lára ẹ̀. Let's see. So we can see the kind of output that it is giving to us. And for those of us that are Yoruba speakers here, right, we can see that it is not so accurate, right? It is not so accurate. While for those that so if you are not a Yoruba speaker, from the beginning of this notebook, I would have expected you to change your model when we're using NLLB, right, to your own language. But you won't be able to do that for this because this model, right, is a specific model for translating from English to Yoruba. If you need a specific model in your language also, you have to check Hugging Face and then check for specific models that can translate from, let's say, English to Igbo or English to Hausa or English to thief, right? Like somebody asked the other time. So still on our revision, right? So here we are now trying to see there is difference, right, between when we use our NLLB model versus the result we will get when we use the small the T5 model, right, the dedicated model. So for NNLB, you can see to every action there's an equal and opposite reaction. Fún gbogbo ìgbésẹ̀, òfin Newton kan wà tó bá mu bá ṣe ń ṣe nǹkan. Okay, and then you can see the result for the small model. You can see that the quality, right, is very different. So let's copy this one, this very simple text, and then also see the difference, right, in the quality. Let's also see the difference in the quality. You can see for NLLB saying àló or àó, nǹkan ń lọ dáadáa. And then you can see the not good result that we get, right, from our small, the T5, right, dedicated T5 model that we are using. I think one question that comes to mind that you'd want to read up on your assignment is, okay, why is NLLB giving a very good, at least good responses as opposed to a dedicated model, right, for English to Yoruba? Okay, so moving on to what we have to do today. Today, we'll be learning how to evaluate this translation model. We know that, fine, we can look at okay, I can see Come Alive saying on your end, ah, top please, even you're saying this notebook is not working on your end. It's saying too many active sessions. Okay, so one thing you want to do before I get to Come Alive, my screen is blurred out. I should please adjust. Okay, sorry about that, Abaju, but my screen is not blurred out, so you might want to check the quality of your network, right? Or also set the video to a higher quality on YouTube. So I'm sure if you try out those steps, um, my screen will be much. Yes, back to top Lizzie, right? What you should do is say you have too many active sections. Are you sure you are not running this collab notebook on different tabs, right? If you are running it on different tabs, please close some tabs, right, that you are running this collab notebook, and then you can restart on the current one that you can restart the you can restart that session. You can even delete the session, right, and then start all over again. So I'm sure you should be able to get a better result and get results for everything you are running when you do that. So I can also say Come Alive. You could not load small model. Name pipeline is not defined. So that's a very simple error. Come Alive. That's because you did not import or you did not run this cell. Let me show you. So that's because you did not run this cell. You did not run this cell here for pipeline, right? So make sure you run this cell from transformers, import pipeline, right? So if you do not run it, if you do not import it, there's no way to know what pipeline is. So that is why you're having that name error. Pipeline, let me see the error said you have again. Yes, name error, pipeline not defined. So make sure you run that cell, and I'm sure you should be able to load your small model. Yes, of course, save a copy in Drive so that any changes you are making, right, on the notebook, it will be saved, right? But if you are running this original notebook given to you, and then at the same time you are also running the you save the saved copy in your drive, and at the same time maybe you're also running it somewhere else, so running it somewhere else, running it somewhere else. So I don't know how many active sections that you have currently on Colab, but for Colab to complain that you have too many active sections, then yes, I'm very sure you have too many active sections. So you'd want to first delete, right, some sessions, right, so that you can easily concentrate on the notebook that you want to run. Okay, since it's complaining that you have too many active sessions, just delete one and then focus on one top pleasing. Okay, so since most of us are now on the same page, most of us are now on the same page. So let's move on to what we have to do today, which is to evaluate, right? Automatically evaluate if our model, right, is giving the correct translation. Fine. From the languages that we understand, we can just, with what we've been doing so far, is just to look at it, right, and say, yes, this translation looks correct to me because you can speak, right, that language. But there's a way to also automatically evaluate, right, this the response, right, from your model. But then to evaluate the response from your model, you still also need the ground truth. So when we say ground truth, So when we say ground truth, right, it is the human translation, right, of whatever you've given to your model, right, to translate, right. So you have this ground truth, which is the human translation of it. I know that, okay, this one is correct, though, this is the correct thing. Then you now give it some English sentences, right. So when it translates, you now compare, look at what my model translated and look at what humans, right, have translated as the ground truth. Then you now begin to compare, right? You now compare and contrast and say, oh, this result is not as good as what we are expecting, or this result is gives a better expectation, right? Okay, so I can see that we have another question. The max is saying, so if you're saying too many sessions rather, if you're saying too many sessions, top is live, can clear your browser's cache and also delete. Don't just close. If you just close the notebook like this, let me come back to my. Don't just close the notebook. Come to runtime, right? Come to runtime and then manage sessions, right? When you click on manage sessions, you are going to see all the sessions, active sessions that you have. So delete the ones that you don't need. As you can see for me, I only have one active session, right? So delete all the sessions that you don't need, and then I think that should work for you. Okay, the Max was asking a question. What causes the running of cell to be showing error? We have different error. We can have different errors, right? In this class, I think two people have encountered two different errors. Somebody was encountering name error because they did not import the library that they were supposed to import. Another person is having, well, you can also have syntax error, meaning that you did not write the code right the way you're supposed to write it. So there are lots of errors that you can have. It's not just limited to syntax or name error that I've used as an example. So anything can cause error. And solving your errors is what makes you very good, right, at what you are doing. So always make sure to read and understand your errors and then try to solve them. So there's no specific way. I can't tell you that, oh, this is what causes errors whenever you are running your notebook. There are lots and myriads of things that can cause different types of errors whenever you are running your notebook. Wow, excellent. You tried the English to Hausa, Abubakar. Great one. Great to see that. Wow, that is for the NLLB model, right? That's for the NLLB model. Excellent. The marks, because you keep getting error. So you have to tell us what type of error you are getting. So it is when you tell us the type of error that you are getting, that is when we'll be able to help you that, okay, oh, this is what you should do and this is what should be corrected. So what type of error are you getting? Yes, thank you very much, Olajumoke. That's accurate. So the marks will be waiting for your response to tell us the type of error that you are getting so that I can provide you with solution. So moving on to how we would now evaluate our translation model. So we use something called BLEU scores, BLEU, right, to evaluate translation. We use something called BLEU, BLEU scores, right? So it takes, like, I'll just explain it on a very high level because you do not need to you can just understand it, right, on a very, very high level without, because you won't be writing the math by yourself, right? So start calculating how to get the blue score by yourself, right? We'll be making use of the library called, let's see, yes, we're making use of the library called Sacred Blue, right? So that is the library that we will be making use of. So before we get to that, let's see what we have here. So here, right, we are just trying to create a function, right? A function that will take a list of English sentences and then you return the translation in your local language, right? So we can decide to use the T5 model that we said above or the NLLB translate. You want to use the T5 model above, you have to set this use small to be true, else by default it is false, and then the NLLB translation will be used. Okay, the max is saying name not correctly in what? You have to, you know, that to debug. Debugging is part of your work, number one. Debugging is part of learning, right? So you have to tell me the full error. Tell me the full error. Like this, I cannot really know how to help you. If you just tell me it shows name not correctly in what? Are you having a name error? you have to give me more context. Exactly. So just like the way we used to say that you should give your model more context so that it can give you a very good response, right? You also have to give me more context so that I can help you, right, to solve the errors that you are having. All right, Oladipoke is telling you that you'll be learning generative AI from week 1 to week 4. Sorry, this is week 6. You'll be learning generative AI from week 1 to week 6, that you can also do that, right, with um the model Gemini, right, which is embedded in your Colab notebook. Well, personally, I wouldn't really recommend Gemini for solving coding tasks, right? Maybe for writing tasks, right, I might recommend Gemini. But for coding tasks, you majorly want to use GPT, Claude, and then Gemini if you don't have any or more option. Okay, so we have the different sentences here. Good morning. How did you sleep? Machine translation is very useful for multilingual applications. So we are going to be calling our function, which we defined above, translate batch, right? Translate batch. So we can this function here, right? And then doing this like this, right? We are using the NLLB model, right? If you do it this way. So if I run this, you can see the result that we got. Báwo lo ṣe sùn? Please, if you are not oh, you can also look for a maybe a dedicated model from English to your own language of choice and then replace it with the model that we are using for our own small model so that you can also compare, right, the results between that model and what we have for NLLB, no language left behind, right? So let me now use um that small language model, and to do that I'm just going to do make use small, right? I'll make use small to be true. So I'll create a new cell, paste this, and then in this function, right, I know that we have another parameter, right, use small, and then I'll make it true. Right. So when I run this, so it's getting the result. So you can see the difference, right, between the one for NLLB and then our T5 model. Ẹ̀rọ ìtumọ̀ èdè. Great. Ẹ̀rọ ìtumọ̀ èdè máa ń wúlò gan-an fún àwọn ohun èlò onírúurú èdè. That's excellent. Ẹ̀rọ ìtumọ̀ èdè máa ń wúlò gan-an fún àwọn ohun èlò tó ń sọ onírúurú èdè. That's correct. I'm sure for Yoruba speakers here, we know that's correct. But look at what we have for our T5 model, right? Ó wúlò gan-an and fún àwọn iṣẹ́ tí ẹ̀rọ ń ṣe fún onírúurú èdè. So you can't even compare that quality, right, to what we have for the T5 model, right? Please make sure you are also following through with running this in your own language, right? Yeah, good morning is car, but it's saying arrow, but at least it's got the morning there, right? So which is good. Yes, well, if you are using Gemini Pro, yes, can be a good option for coding. Yes, yes. It's just my own bias, right? It's just my own bias. So you don't have to follow my own bias. I think for Gemini Pro, yes, it can be a good option for coding. Yes. Okay. So for Yoruba speakers, you can see that we cannot. Yeah. Good morning. I think who said that? Uh, Yes, top Lizzy. Yes, but at least he still got the money and he tried. As opposed to what do we have here? Òwúrọ̀. Báwo ni o ṣe sùn? Báwo ni oorun ẹ sùn? Báwo ni is even repetitive, right? Báwo ni oorun ẹ sùn? Báwo ni oorun ẹ sùn? Báwo ni oorun ẹ sùn? As opposed to the good translation at least that we have for um NLLB. So one thing you can also do, right, when you are thinking of your project, you can also take this one step forward, right, and think of how to, let's say, fine tune maybe a translation model and then see how it can give you better result, right, when you are translating from English to your own local language. But you have to like put in more work, right, to be able to do that, right, for your project, because the scope of this class would not cover fine tuning, right? So moving on to evaluation, right? To now evaluate, just like I said before, we need ground truth. We need a way to compare. We need a way to compare yes, we need a way to compare the prediction, right, from the model with the what we know, right, that is true, what we know to be true, right? We need a way to compare it. So one metric, right, that will help us with that comparison is called BLEU score, just like I said before. So what we just have here is we have some sentences in English, right? And then we have some original translation, right, from humans, right? 1, 2, 3, 4, 5. So if you are not a Yoruba speaker, right, for Abubakar, right, for each of these sentences, you could translate it to Hausa, right, and then see the score, right, that your model, the blue score that your model is going to be giving. So you could translate it yourself, give it the ground truth that you know that okay, when you translate this sentence from English to your own language, this is what it should give you. Right. So I'm going to run this now. So I have 5 English sentences. So we all know that length is just to show you the number of things, right, that you have maybe in that list. We are using list here, right? So here we have 5 English sentences and also 5 Yoruba sentences, which is the translation, gold standard, right, or the ground truth of what we expect. So now we now evaluate, right, with BLEU score. We now evaluate with BLEU score. So before we come to this part, let me give you a very high level explanation, right, of how this BLEU score will work, because it is not just, this is text, right? It is text what is being translated. And even if we are speaking the same local language, if they give me a sentence in English, the way I'm going to translate the sentence will be different from the way Toplizzy, right, is going to translate that same sentence. So how does this blue score, how does this measure, right, accuracy? So let's see that by looking at this Medium article together. So I can see Olajumoke saying you should include fine tuning for us. Oh no, this, but it's something you can always take a step forward to learn on your own. Just like I told us before that organ face, right? I'm sure I've told us in this class before. We know that we can use models from organ face. We can also push our own models, right? That maybe we fine tuned or something to organ face. You can also learn, right, from organ face. So if you want to learn about fine tuning, which will not be covered in the scope of this class, right, just go to organ face, right, do the NLP or LLM course, right, on organ face, right. I'm sure you would understand it. And you've been taught how to do prompt engineering, how to ask your model questions, right? So any part you do not understand, because we might have been done with this class by then, any part you don't understand, you can also always ask, right, model to guide you. You can ask Claude, you can ask GPT, or you can ask Gemini also. Yes, exactly, Moses. You can use your own language. So let me give us a very high level understanding. We can always go and read this article right after this class. I won't be explaining the maths part too much. So I'll stop sharing this um notebook, and then I'll share this. Okay, so we have this very simple medium article here introducing to us um blue score, right, and what's how this metric, right, is being calculated. So you are, please, I'm saying that we do this on a very, very high level, so we won't be going too deep, right, into the math aspect. My screen is blank. I'm actually resharing my screen. Okay, great. I'm sure you can see my screen now. I'm sure you can see my screen now. And the marks, yes, you didn't tell us the um error that you were having again. Please tell us the error you were having. And if you've been able to solve it, then that's excellent. Yes, I know you can see my screen now. Great. So there's something called ngram, right, in text processing, and it's not actually specific to NLP or Blue Score. It's just a way of saying the number of words, right, that you want to concentrate on in a sentence. So that's the way to explain it. So when you hear unigram, uni means one, meaning you just want to concentrate on one word, right, in a sentence. Bigram, two words you want to concentrate on. Bi, two words, right, in a sentence. Trigram, you want to concentrate on three words in a sentence. And then four, we want to concentrate on 4 words, right, in a sentence. And it must be in a sequence. Yes, it must, the order is very important, just like we can see here. The ball is blue is not the same thing as blue is the ball, right? So that's the first concept we want you to understand before we explain that blue score, how it works. Because if I were just learning this, I'll have a question in my mind, just like I said before, that how would we be able to validate, right, translation, which is just pure text, right? And then you need to also understand the precision part aspect of things, which is looking at the number of correctly predicted words, right, divided by the total number of words, right? So in our target sentence here, you can see that we have 4 words: 1, 2, 3, 4, right? Out of these 4 words, how many can we see in this predicted sentence? We can see e, we can see an, and we can see apple. So that's 3. So the precision will be what? 3/4, right? But this precision, using it like that, is not good enough. Yes, it's not good enough, because if there is a repetition, right, we'll be saying we are having a perfect precision, which is not the case, right? So that would lead us to something we call clipped precision, right? So one thing we want you to know here is that instead of um going with the repetition, right, instead of repeating those words, what we do here is to compare each word, right, from the predicted sentences, right, with what we have in our target. In our case, the target is going to be the ground truth, right, the human translations, right? So anyone that matches the targets will consider it. So if you don't understand it, don't worry. Let's look at this simple analogy here. So the first one, we have our target sentence, which is, let's say, the human translation. That's the ground truth, our gold sample, right? Ground truth majorly is he hits a sweet apple. Another target sentence is he is eating a tasty apple. So, and our model now predicted E 3 times, he hits a tasty fruit. So let's now go to this table now. He hits a tasty fruit, right, is what was predicted, right, by our model. So let's now look at which one matches, right? When we look at E, it is matching um the 2 sentences, right? Target sentence 1 and then target sentence 2. So you can see that that's why we have both here. It is only matching 1 sentence, which is target sentence 1, it and the predicted sentence, right? Which is why you can see um target 1 here. While for tasty, you can see that it's just matching target sentence 2, right? So that's why you can also see it here. And then fruit is not matching any of our ground truths, right? So if we now count it, right, matched predicted count, right? If we look at E here, E is occurring 3 times, right, in our predicted sentence, right? 3. That's why we have 3 here, because it's occurring 3 times in our predicted sentence. And then if you look at the target 1, right, it's just occurring how many times? Once in our predicted sentence, okay? Tasty, right, is just occurring what? Once in our predicted sentence. We are not concerned about foods because we do not have it in any of our ground truth, which is target sentence 1 and target sentence 2. Right. So if we are now looking at the clip count is saying that we limit the count, right, for each correct word to the maximum number of times that the word occurs in the target sentence. So the maximum number of times that E is occurring in our target sentence is just 1, not thrice, right? It's just once, right? So that is why you are going to change this one, right? This our click count to what? One, and then it two is only occurring once, and taste it is only occurring once. So that will now help us solve the issue of repetition, right? Whenever we are looking at precision of the number of words that our model got. It's just to limit the count, right, of each correct word to the maximum number of times it occurs in our ground truth. So we are more concerned about our ground truth. If the model likes, it should say that word 10 times. If it's occurring once just in our ground truth, it is just that once that we are going to count it. So now you've understood the two basic aspects. Now we'll now use this to build on how BLEU score works. If you understand the n gram, 1 gram, you're just looking at one word, bigram, just 2 words, trigram, just 3 words, and then you can have 4 grams. So it just depends on the number of words you want to put together to check how well the model is predicting what it is supposed to predict. And then order is very, very important here. So now how is the BLEU score now calculated? So the first thing is to now use that so let's take an instance here. Let's say the predicted sentences the guard arrived late because of the rain, right? And then a human translator, which translated the ground truth, said the translation should be the guard arrived late because it was raining, right? Why the model predicted the guard arrived late because of the rain. So what are the words, right, that match? If you are using unigram, right, you just be looking at it 1 1 1 1 1 1. So D matches D, guard matches guard, arrived matches arrived, late matches late, because matches because. So how many words do we have? 1 2 3 4 5 6 7 8. Right? So 8 words. 1 2 3 4 5 6 7 8. So that is 5 out of 8 will be our precision. So now the same thing also for the 2 gram. So you'll be picking the words 22 and then you get your result. And then the same thing for the 3 gram, pick the words 33 and then you look at the result for the precision. Then there's something now called the geometric average precision scores. You do not even have to mind this math at all, right? All you just need to know is that all the precision scores above, right, it will be combined, right, in this geometric average precision scores, which you do not have to bother about. Then the last step, right, the third step, right, we will now be to compute the brevity penalty. And what this does, right, is that the precision, right, what it does is that it outputs a predicted sentence. So the brevity, what it does is just to offset whatever issue that might have come up, right? So whenever you are using the 1 gram precision. So in simple words, that's just what it does to offset, right, whatever issue that might have come up with the 1 gram precision. And then the BLEU score combines all this together, the brevity penalty multiplied by that big formula, right, that we put in our different precision scores in. So if you are going to explain to someone else, right, how the BLEU score is calculated, you know you have to understand the 1 gram, the gram part, n gram, right? So if it's 1 2 3 or 4, right, and then you know that based on the number of words that you need to look at, together, right? You are going to calculate the precision for 1 gram, for 2 gram, for 3 gram, and then for 4 gram. And then you know that all this will now be passed into that a formula called geometric average precision And then there is something called brevity penalty that this will be multiplied by, right? And you do not even need to know how to calculate this thing on your own, because we already have a very good library, right, that would help us to calculate it. So that is why we are now using the Sacred Blue library here, which will help us to calculate our blue score. Blue score is always between 0 and 1. So if you are seeing but the result that we have from the Sacred Blue is already been multiplied by 100. So whenever you are seeing that 0.13, multiply that by 100, you'll be getting like 13%, right? We are having like 0.60. If you are multiplying that by 100, nobody will be getting 60%, right? So that is the score that you can have for a blue score. And it is very hard to have that one, because even as humans, if we are given the same sentences to translate, right, we are not going to translate it the same way. We are not going to have the same words, right, in our translation. So the most very good score, right, that we can have, blue score, will be between 70%, 60%, right, to 80%, right? Having that perfect one is almost nearly impossible, or say 100%. All right, so here now we are using our translate batch to translate our source sentences that we defined here above. And you know that we have our reference locale. So here, right, we are using NLLB, since we did not set use small to be true. Remember, in our translate batch function, right, you want to use the T5 model, you have to use small and then set it to be true. But here we didn't do that, so that will be false by default. So when I run this, can see that we're having a blue score of 13%, which is very, very low, right? Very low. Let's see the results, the blue score we are going to have when we say use small is true. Can you see, even the blue score is now worse, right? This is just 6%, right? 6.5%, which is very, very worse than the one that we had before. So for, if I think if you are using another language, you should just use the one for NLLB for now. That is, you do not need to use small, right, to be true, since I'm sure you will not have gotten a specific model, right, for translating from English to your own language of choice. So you can just use NLLB and tell us the blue score, right, that you got, right, from giving the ground truth in your own language. What is the blue score that you got from that? You can say ours is not so good. I just say 13%, that's 0.13, which is not a great score. So if you're using another language, let us know the blue score that you get, right? The blue score that you would get, right, from doing that. Oh, okay, I can see the max has already given us the kind of error that it's having, which is name error, local language name not defined. Exactly. So now that you've given me context, yes, I can help you. So we defined a variable above called local language name. Excellent, Olajumoke. I can see Olajumoke has already given you a response. Great one, Olajumoke. Yeah. Yeah, so you don't have to be so scared about the maths, right? So that was why I just ran through. You do not have to really be scared about the maths. All you just have to do is understand the high level, right? Understand on a very high level how blue score works. You understand the end gram part of things, the precision, the brevity, and then the big formula that is going to be multiplied with. That's the geometric um what's the full name again? That's a geometric, yes, average precision scores. I know that that one is just what putting all the different precision scores together. So on a very high level, you should just be able to explain that and not be scared, right, of the formula. Yes, so I can see Olajumoke is helping you with that the maths. So for other people that are using another language, right? I can remember Abubakar, apart from Yoruba. What is the blue score that you got from English to Hausa? Let us know. What is the blue score that you got? My screen is blank. Wow. Are you sure my screen is blank? Please confirm if my screen is blank on your end. Okay, so Oka for Lizzie, please, you want to check your network if my screen is blank on your end. So please, Oka, please check your network if my screen is blank. Abubakar, I'm still waiting for your response, right? So that we'll be able to see if NLLB performed better, right, on English to Hausa than English to Yoruba. Okay, so we've seen and compared the blue score we got when we used no language left behind versus our T5 model, and the blue score for NLLB, even though not so great, right, still surpassed the one for our T5 model, right? So apart from looking at the using blue score, right, it's also always advised to just go through what has been interpreted, right, so you understand the quality, right, of translation. So this part is telling us that instead of using a pure translation model, you can also use an instruction tool model, right? So T5 or FLAN T5. So this instruction tool model are models that you can give prompts to and say, oh, do this, right? Then it will help you to translate um, from uh, the your local language to your language of interest. Sorry, from the source language to your language of interest. Okay, no, so now we are using this Flanty 5 model, yeah, and then we are using auto tokenizer to get the help us load the perfect tokenizer for this our model, and then this will help us load our model weight. We all know that. So here we are now passing the input local language name, right? We've already put it down, above, right? we set our local language name to be Yoruba, right? And think that was the error that the Max was having. It probably didn't run that cell. So that was why we were having an error of, oh, it is that variable is not defined because you did not run it. Right. So, and the prompts that we are now giving is translate this sentence from English to our local language name that we defined above is Yoruba, right? So, and then we pass whatever prompt we have to our tokenizer, and then we generate the translation, and then we get our results. So for now, right, the local language that we are using is Yoruba, but I'll change it soon. But let me see the results it will give us here. Large language models can be used for many tasks, including translation. So let's see what Google's Fancy 5 is going to give us. All right. So you don't have to think too much about the maths aspect, just like I said before. Just understand on a very high level what is going on, right? You can't be telling someone you learned about blue score, right? I don't know about engram or either the precision or how everything is being um put together in a formula, dynamic in a formula called, yes, the dynamic, sorry, geometric average precision scores, right, with the brevity penalty, right? So that is something you should just put in mind and then understand it. All right, so moving on. Yes, so let's see the results we are going to get from Flancy 5. So let me run it. What kind of response is this? Can you see the very terrible response that we have? So let me change the sentence right into something more simple. Let's see. So we are not even getting a very good response here. Let me change this to be sure it is Yoruba. Right. I could actually have just printed what we have in that. Well, let's do Control C, Y, and then we'll see. Let's see what's contained in this variable local lang name. It's actually Yoruba. Yeah. So why is it not giving us coherent response? Yeah, same thing. Let me do PGen. It's giving me the same thing back. Instead of saying how you did. So we can try out research other models, right, that you can use for translation and then see how they compare, right? See how they compare to the models, right, that you have been taught to use, right, in class. So the last part of this notebook would also be seeing we have our test sentences in English, and then we want to translate with both NLLB. So you can see this, um, our T5, and also the instruct model, that's Google's Plan T5. No, this is the instruct model is, yes, Google's Plan T5, while the model we are using before was by T5 by David Adelani. Okay, so we want to compare these three responses, right? And then we'll see the results, right, that we would have. But before running that last part of this notebook, oh, I can see Abubakar now. So Abubakar now has given us the blue score he got from English to Hausa. And that's terrible. Just 1.73, right? 1.73%, right? That's 0.01. So we can see some of the gaps already in models, right, that we have, and you can work on solving, making all this better, right, for your projects. So Abubakar translated from English to Hausa, and then we can see the blue score that he has. Midnight is Oru in Yoruba, is Oru. Ọ̀sán is afternoon. Okay. So yeah, so let's see. We have these sentences here. Please submit your assignment before midnight. And the new policy, artificial intelligence is this and that. So run this for our different models. So you can see NLLB saying, please submit your assignment before midnight. NLLB said, jọ̀wọ́ fi iṣẹ́ rẹ ránṣẹ́ kí ọ̀sán tó dé. So that is wrong. Ọ̀sán is not midnight, right? Òru ni midnight. So you can see, oh, the instruct model, I've changed this to pidgin, so that is why you can see it's giving. So let me change the instruct model here to Yoruba back, so we'll see what it's going to respond with. Right, so this instruct model that we use here, it is the base, right, model. So you can also, on Hugging Face, you can check for models that people have fine-tuned, right, and then use that in place. That will be your assignment for this week. So use that in place of this Flan T5 model. Look for models that people have fine-tuned. I'm sure you get them on Hugging Face. Replace that with this model here, and then see if there will be any improvement, right, in the response that you are getting. So for NLLB, it's tried, but it's not fully correct, and then this our BT5 is not even giving a coherent response. For the next sentence, the new policy would affect many small businesses in the community. Ìṣèlú tuntun yìí yóò nípa lórí ọ̀pọ̀ àwọn ilé-iṣẹ́ kékeré tó wà lágbègbè náà. That's correct, very very correct. Let's see the small, our by T5 model saying ìlànà tuntun náà yóò nípa lórí àwọn oníṣòwò kéékèèké tó wà lágbègbè náà. That's also right. So even though we have different versions, right? So that's right. But I even prefer the by T5 to what NLB is translated, because this one is saying ìṣèlú tuntun, like politics on it. But also in a policy ìlànà in Yoruba. You can check what that also means, right, in your language, and then see if it will give you the correct one. So an assignment for you, right, this week, you can build a simple web app, right, based on what you've learn how to push it to your Hugging Face space. Try taking it a step forward by fine tuning. If you can do that on Hugging Face, you find a lot of materials, right, to fine tune. You can also just look for models that people have fine tuned, right, and then replace it with this Plantify here to see the type of response, right, that you would get. Yes, the batch 98 fine-tuned model is for Pidgin, right? That one is for Pidgin. Your blue score is 13.4. Yeah, that's also the same thing, right? When we check the blue score, where is it? Where is it? It's the same thing. It's the same thing. Yeah. So we are using the same sentences and the same ground truth, right? So you are going to get the same thing. We are going to get the same thing, right? You did it in Igbo. Excellent, Diamond. And your blue score is 0.8. Wow. That's not good though for NLLB model, right? Meaning NLLB is not doing so well on Nigerian languages. And I'm sure you can work on that also for your project. So it's great to see us all. We have come to the end of the 6th week, right, of our class. When we come next week, 7th week, right, of this bootcamp, we'll be seeing different health applications. My colleague will be taking you through different health applications, right, of generative AI. So thank you all for staying from the first week up to this time, and see you all next week. Bye.